Hello students, welcome to chapter 13, limits and derivatives. Students, in derivative continue today, we going ahead our exercise 13, question number 2. But before starting this video students, I just request to you just write down your formula list at least 1 or 2 times. And then after start these parts. So in these parts, we going ddx of x plus a, very easy, ddx of x and ddx of a. Our working rule, here 1 but here 0 because constant, and that become your answer 1 only. Now second, ddx of px plus q into r next upon x plus s. It is you consider, that is v, and both apply our product rule. So first, second derivative r by x plus s plus second first derivative ddx of px plus q. Just I will write down product rule. Now answers one by one. It has to px plus q. Students, here r constant, but 1 upon x derivative minus 1 by x square, and s derivative it is constant 0 plus r by x plus s. And here p, but x derivative 1 and q derivative only constant 0. Now you will take to multiply inside one by one. So your first multiples, px with the minus r by x square plus q with the minus r by x square. Same here, p r by x and last ps. So you easily cutting that, one of the xx gone. You have to only one data remaining, one of the minus pr by x, minus qr by x square plus pr by x and plus ps as it is. Students, this cancel, pr by x and only your data minus qr by x square plus ps, and that's your easily question number 3rd done. So only your data qr by x square and px. Continue question number 4th, ax plus b ddx of into cx plus d raised to square. Yes, here also I will go to product rule, that become consider one of the u and second consider one of the v. So first, second derivative cx plus d as it is square, first second derivative over. Now plus second first derivative ddx of ax plus b, and only operate your product rule. So students, here very easy, I just show here ax plus b same as here apply. First of all, I will here first time chain rule apply. This consider one of the x and power raised to 2. So x power raised to 2. So x raised to 2. I will show that 2 times raised to 2 minus 1. And this derivative pending. Which derivative? Cx plus d. Again repeat, this is a chain rule, not a multiplicative rule. This consider is x power 2. So 2x raised to 2 minus 1 and cx plus d derivative as much as same as plus next one cx plus d square. Here a x derivative 1 and b derivative 0. Now you will cover to your answer ax plus b into 2 cx plus d raised to 1, and here derivative I will show that a cx derivative 1 but d derivative 0 plus the same as cx plus d square into a. Now after that rearrange, and students, maximum common taking to overall. So in have to common taking, one of the common is a cx plus d one time only. So Cx plus D common, remaining are 2 times ax plus b, and here students with c also remaining, so twice c here pending, twice c and ax plus b, and that become a but cx plus d, and that's your finally just to multiply inside also, so your answer is cx plus d remaining twice acx plus twice bc, twice acx plus twice bc, and last plus acx plus ad. Students, here you check acx and acx like term, so my answer is a cx plus d with the 3 times acx twice bc plus ad, and that become your finally answers going ahead, thrice ac, bc and ac and only ad. Now continue question number 5. ddx of in the same range, fifth one, ax plus b upon cx plus d. One more time check, ax plus b upon cx plus d. So it is here I will go to simple division rule. Yes, u by v rule. So in division rule, you know that in denominator square, now in denominator ddx of numerator ax plus b minus now numerator ddx of denominator cx plus d, and simple apply u by v functions. So cx plus d same, here apply the derivative a x derivative 1 but b derivative 0. Continue ax plus b, here c x derivative 1 but again d derivative 0, and last as it is. Now just multiply to each other, that here multiply and that is also a. So my answer is acx ad. Similarly minus acx minus bc, and last of the same as cx plus d the whole square. Indirectly acx and acx students easily and happily cancel. Only remaining data ad minus bc by same is, that's become final answer to that questions. So ad minus bc upon cd cx plus d the whole square. It's very easy questions. Now continue question number 6th one. Students, now numerical coming to now bigger 6. Yes, 6 also one of the short sum, don't worry. ddx of 1 plus 1 by x upon 1 minus 1 by x, 1 plus 1 by x upon 1 minus 1 by x. Simple, take LCM. So ddx of, here LCM x plus 1 by x upon x minus 1 by x. So does this x and this x easily cut out. Only remaining you have to x plus 1 below x minus 1, and here you start our simple division rule. So in denominator square, now in denominator ddx of numerator minus numerator ddx of denominator, and now we'll start simple your formula x minus 1, this derivative 1 but 1 derivative 0, minus similarly here 1 but here 0, and downwards as usual. Now students, simply you just expand the terms. It will be x minus 1 minus x minus 1. So this x and this x successfully cancel. Only your answer is minus 2 below x minus 1 square and minus 2 by x minus 1 whole square. Our last answer. Now continue question number 7. Yes students, now coming the big questions, till to 7 running. Question 7, ax square plus bx plus c in denominator given. ddx of 1 upon ax square bx plus c, and going ahead simple or simply to simply division rule. This consider u and that consider v, and u by v rule, students. So in the denominator square, first of all I will show you. Now in numerator, denominator start d dx of 1 minus, now 1 d dx of ax square bx plus c. Now you will show that simple to simple your answer. So my answer is ax square bx plus c, but here constant derivative 0, minus here derivative take twice ax plus bx, derivative 1 and c becomes 0, and that same is ax square bx plus c the whole square. That is completely 0 because the 0 multiply, and here same is twice ax plus b ax square dx plus c the whole square. Indirectly my answer is twice ax plus b upon ax square bx plus c the whole square, and that's your finally answer, students. Next, continue question number 8. 8 much also same is to 7th. Yes, very interesting question, students. In the 8 is the IMP d dx of data available in the numerator ax plus b, that become ax plus b, and downwards px square plus qx plus r, again px square plus qx plus r, and upper way ax plus b. Simple division rule apply. In denominator square px square plus qx plus r the whole square. Now formula operate to denominator square. Now in numerator, denominator value first d dx of ax plus b minus ax plus b d dx of denominator px square qx plus r. Simple, I operate here division form u by v rule. Now you just create your derivative one by one, showing that here a x derivative 1 but b derivative 0, minus ax plus b, that become twice px q x derivative 1 but r derivative, students, 0, and upon downward same as px square qx plus r the whole square. This a multiply and that a multiply until expand the fully. So here a px square a qx ar, but that side minus also multiply, and inside the expansion minus ax now multiply. So twice apx square minus aqx minus b twice x, b into p into twice x, minus b into q, and last denominator same is px square qx plus r the whole square. So this is a like terms, apx square and twice apx square, and also aqx cancel one time here, but here minus 2 times, it means minus 1 times apx square. Other data same ar, here minus twice pb x and last bq, minus twice pbx and last bq upon same as px square qx plus r the whole square. Here, students, that much is completely answers. Now 9th one is a completely reciprocal of 8 questions. That much also IMP for exam oriented. Yes, question number 9. So tick mark in IMP list ddx of px square plus qx plus r upon ax plus b. One more time check. Qx square plus qx plus r upon ax plus b means exactly reciprocal of the 8th sum. Here also students, I will start my division rules in denominator square. Now numerator, for forming that start first denominator ddx of numerator. Simple, apply your division working rule minus now numerator ddx of denominator ax plus b, and now operate simple formula. So ax plus b same is here derivative twice px plus q x1 but r derivative 0 minus px square qx plus r into now here derivative a x derivative 1 but b derivative 0 constant and upon as usual students. Now you will try to multiply here and that also you multiply one by one. So your first multiplication with the ax, that multiply twice p ax square plus a qx, now b chance twice pbx plus bq, and here same as to multiply a px square minus a qx minus ar, and downward same as ax plus b the whole square. So it is here also you check aqx com, that's the like term twice apx square and one time apx square, twice apx square minus one time apx square, it that only one time apx square. Another same as twice pbx plus bq minus ar upon same I will write down ax plus b the whole square. Here no data is repeated, and that's your answers. Now continue question 10. In same way, in same focus, just using their division rules working rule. Question number 10, ddx of similarly a upon x raised to 4, next second x raised to 4 written, minus b upon x square plus cos x. So a upon x raised to 4 minus b upon x square plus cos x. Simple, you just separate all three terms by using your working rule. A with the x raised to minus 4 ddx, b with the x raised to minus 2, and last with the cos x. Working rule apply. So here answer is a minus 4x raised to minus 4 minus 1, just like n a raised to n minus 1. Same here students, minus 2x raised to minus 2 minus 1, and cos derivative you know that which is only and only minus sin x. So my answer is minus 4a x raised to minus 5 twice b x raised to minus 3 and minus sin x same is. In short, my answer is a minus 4a by x raised to 5 plus twice pb x raised to 3 and minus sin x as much as same is. And that the students, your answer is done. Now continue question number 11. So indirectly very easy numerical, but if you properly by heart the formula, then now 11th one. 11th very short question. ddx of 4 root x minus 2, 4 root x minus 2. Simple, but root x I will take in the form of 4x raised to half minus d dx of 2. So here 4 same, and that derivative is half x raised to half minus 1. And here constant, but constant derivative, students, you know very well, that's exactly 0. So that cancel 2's. So 2 x raised to minus half. In short, my answer is 1 by x raised to half. So it create 2 root x. So your final answer is, students, 2 by root x. Yes, and here constant derivative is 0. So over that only 2 by root x derivative. Now continue. If you direct going, then 4 root x derivative 1 by 2 root x. Then also cover your answers. But you show the method wise is best. Continue. Question number 12. d dx of, in the same version, 12th one. Now start our chain rule here, students. Ax plus b raised to n power. So in chain rule, you just focus here. This parts you just consider one of the x. And this reading is n. X raised to n. X raised to n. You know that? Yes, which is n raised to n minus 1. So your n. Ax plus b raised to n minus 1. And here this derivative is remaining by chain rule. One more time repeat, students. Chain rule means nothing. Whenever you power it more than 2, 3 given, then you operate that. This considered is x raised to n. So you apply the derivative x raised to n by nx raised to n minus 1 and ax plus b pending. Now I will show the derivative ax plus b. So n ax plus b raised to n minus 1. Here a x derivative 1, but b derivative 0. So my answer is done here. Na into ax plus b raised to n minus 1. Now question 13. d dx. 13 is a IMP numerical. It is a most IMP for exam related. So tick mark in IMP list. Ax plus b raised to n and cx plus d raised to m. Question check again. Ax plus b raised to n and cx plus d raised to m. So does this half questions already repeat here? I will show that in the product form first of all. So by working rule, first second derivative cx plus d raised to m plus now second first derivative d dx of ax plus b raised to n and operate the formula by chain rule. So ax plus b same raised to n. So it is here I will show my working rule. This consider it will be x raised to n. So my derivative m cx plus d m minus 1 and d dx of cx plus d pending. Now second same as plus cx plus d raised to m. Here n ax plus b raised to n minus 1 and this derivative is pending, students, ax plus b. Correct? Only I just show here working rule for our chain rule. Now I will show the derivative to internal parts. So ax plus b raised to n and that will be m cx plus d raised to m minus 1 and here take the derivative d dx of c x derivative 1 but d derivative 0 plus cx plus d raised to m that is n and another here same as ax plus b raised to n minus 1 and now students here derivative ax plus b it is a x derivative 1 b derivative 0. Now I will take to common. First of all rearrange the students MC, then after I will take to common Cx plus d raised to m minus 1, and here Na remaining are Cx plus d raised to m and Ax plus b raised to n minus 1. Students, always you take the common by least to least priority. So this is the least priority in compare of that, and that is also least priority in compare of that. So I will show the common here, Ax plus b raised to least power, same Cx plus d raised to least power, and remainings are as it is. This and this are common. Here remaining are m into c, Ax plus b raised to 1. Check, this power and this power are base same, priority addition, n minus 1 plus 1, it will be n plus Na. Here this priority least common taking, so that are remaining Cx plus d raised to 1. So indirectly my numerical is done. Ax plus b raised to n minus 1, Cx plus d raised to m minus 1, and that is same as mc Ax plus b plus Na Cx plus d, and that's your finally answer, students. Now continue question number 14. 14 is very easy and very simple. This 14 question, students, I explain you both way, directly and chain rule, sine of the x plus a. Question 14, ddx of sine x plus a. First of all, going to our chain rule. Consider this sine. This is one of the biggest x, sine x. Sine x derivative known, cos x, and remaining are as it is by chain rule. By chain rule. So my answer is cos x plus a. X derivative 1, but a derivative 0. In short, I will challenge that your answer is cos x plus a. Now another method, the same numerical I explain again, students. You both have the understood necessary. Here the formula operate, sin x plus a, which is the ddx of sin x cos a plus cos x sin a. And two constant functions take outside and first variable inside. So cos a outside, ddx of sin x plus sin a outside, ddx of cos x, students. Now you operate the simple way derivative. So cos a same, sin x derivative will be cos x plus sin a cos x derivative minus sin x. So cos a cos x minus sin a sin x, and that becomes, students, one of the your simple formula. Yes, cos of x plus a, and that the, students, this answer and this answer, you check your final answer is very easily, students, here done. Now students, after ending this question number 14, I will stop this video, and further explanations to question number 15 I will explain in the next parts. Bye students.